On a clear, dark night between November and March, you can see these stars from almost anywhere in the world. On the right is the constellation of Orion, the mighty hunter in Greek mythology. Beside the figure of Orion in the sky is Sirius, the brightest star in the heavens. Sirius is 8.7 light years away, a neighbor of the Sun. Only 6 stars are closer. It lies in the constellation of the Great Dog, Canis Major. Sirius is Alpha of the Great Dog. Other bright stars in this constellation are also labeled with Greek letters. Sirius is also called Alpha Canis Majoris. We're going to look at Sirius with very high magnification. Our time rate is speeded up so that 5 years pass every second. Because Sirius is relatively near, it appears to move against the background of much more distant stars. This is what astronomers call the proper motion. But instead of moving along a straight line, as we would expect, Sirius leaves a slightly wavy trail. The wavy motion tells us Sirius is orbiting about another star that is too faint to see. In other words, Sirius is one component of a binary system. Let's take a closer look at this. Let's mark the imaginary point around which Sirius appears to move. Sirius makes a complete revolution every 50 years, or on our time scale, every 10 seconds. But if Sirius is one component of a binary system, where is its companion? Well, if the imaginary point is the barycenter of a binary system, then the companion must lie somewhere along this line. Of course, the companion must be on the opposite side of the barycenter, the exact position depending on the relative masses of the primary and the companion. The companion must be very faint, perhaps not shining at all. Let's move still closer. Here at last is the companion of Sirius. The barycenter is clearly not a focus of the elliptical orbits, so we must be viewing the orbital plane at an angle. We can calculate from the position of the barycenter that the companion has a mass that is 42%, nearly half, the mass of Sirius. Since the distance to Sirius is known, astronomers can calculate the size of these orbits and the masses of the individual stars. The mass of Sirius turns out to be about 2.5 times that of the Sun. The mass of the companion is about equal to the mass of the Sun. We'll take a closer look at both of these stars. We're now close enough to see the disk of Sirius. And here's the size of the Sun for comparison. But the companion is still just a point of light, even though it has the mass of the Sun. At last, we're close enough to see the disk of the companion. It's as small as the Earth, a kind of star astronomers call a white dwarf. Matter in this star is squeezed so tightly by the inward pull of gravity that even the electron shells of the atoms have been crushed. A cubic inch of this material has a mass of several tons. As queer as these stars seem, they are common. About 3% of the stars in our galaxy are white dwarfs. Some, perhaps all, are remnants of exploding stars. Whatever their origin, white dwarfs are dying stars. Their supply of nuclear fuel is exhausted. They're slowly cooling and will become red and finally black dwarfs, stars that no longer shine. Sirius gives us just one example of how peculiar star types may be discovered and studied in binary systems.